Hello everyone, welcome to my channel. Today I would like to show you how to use recursion in LabVIEW. Recursion is a very common and useful technique to solve programming problems. However, from my work, I don't see a lot of people are using it very often, so I would like to make a video to show you step by step how to do that in LabVIEW. So the problem I would like to use as a medium to demonstrate this method is the Fibonacci sequence. I would like to show you how to get the nth order Fibonacci number first, and then how to show the sequence. So let's say the input, so the problem description. So we need an index, and we also need the Fibonacci number. I'm just going to call it Fib number. So the index, let's define it as a natural number, meaning that it is a positive whole number that is non-zero. So let's just assume this is a given. And the first Fibonacci number would be 0, 1, the second would be 1, and the third number would be the sum of the previous two, which would be 1. And if you apply the same rule, you get 2, 3, 5, 8, 13, this is 21, and 34, and etc., etc. So let's take a look at the method here. Typically, when we apply recursion technique, there are two things that we want to be very clear about. First, we want to ask ourselves, what is the base condition for this problem? And second, we want to ask, what is the recursive criteria? Now, in this problem, the base condition is that when the first number, if the size of the sequence is 1, then we want to return the first number, that is 0. And the second number would be a 1. So these two are given, right? Because without a base condition, we cannot establish a foundation for the recursion to work. So let's write some pseudocode. So if index equal to 1, then return 0. And if index equal to 2, then return a 1. Now with the base condition established, let's see what is the recursive criteria. As I've shown you before, that the way we derived the third Fibonacci number is to sum the previous two, and the fourth number would be the sum of the second and the third, and etc., etc. So the recursive criteria would be if the index is equals to or greater than 3, then we want to return the fib index minus 1. I'm just going to use I representing for the index, and plus fib I minus 2. So the fib I minus 1 is the, by the way, the fib is the notation for the Fibonacci function that we're trying to implement. This function by itself is recursive. So passing in I minus 1 represents for the Fibonacci number immediately before the ith order Fibonacci number. And I minus 2 would be 2 numbers before. So now we have the algorithm down, we can start implementing using LabVIEW. Let's move this aside a little bit. And let's say, let's save this, actually. So let's just save it. Desktop, I'm gonna call it get fib number. Okay, so let's add a case structure here. And we know that we have an integer input, right? Because the input is the size, is the size of the sequence, which is a natural number. So let's find a control. Let's change the representation to unsigned 64-bit, and let's call it sequence size. Actually, let's just call it index for consistency, to be consistent with the naming here in the spreadsheet. And connect the input to the case selector. So we want to add a couple more cases. So from the table, we know when index is equal to 1, we want to return a 0. Okay. Smaller. Okay. And when the index is 2, we want to return a 1. And when the index is 3 or greater than 3, we can represent that case with 3 ... We want to return the sum of fib1 and fib2, right? So let's do this first. Let's create an indicator. So this indicator would be our output fib number, right? And let's move back to the front panel, and let's assign the input terminal and the output terminal. Okay, save it. Then, so here, watch me. So click on this icon, drag and drop. Now you see this thing is grayed out because the VI cannot call itself. It creates a condition, a logic condition that's invalid. And I'm going to show you later how to fix this. So in fact, you need 2 instances here, because what you want is to call itself twice. First, you want to derive the fib I minus 1 case. So with the constant 1, connect it to here. The I would be the index minus 1, and pass that as the input of the fib. And then you want to compute the I minus 2 scenario. So you pass that into the second instance, and you want to sum it up, right? As we showed up here. And we can actually make this case as our default case, because most of the cases will probably fall under this case. And the 0 is actually an invalid case, but let's just assign the default for the sake of simplicity. So here's the next step is the key. Go to File, VI Property, go to Execution. You will see that the non-reentrance execution is selected by default. In order to make this VI a recursive VI, you want to change that to the second option, which is Shared Clone Reentrance Execution, and hit OK. Now you see the difference. The previously grayed out VI is currently no longer grayed out anymore, and the VI is no longer broken. So let's save it and test it out. First, let's test our base condition. If index is 1, it should return a 0. If we run it, indeed it is 0. If the index is 2, that's our second base condition. It should return 1. Let's try that. How about 3? The index 3 should be the sum of fib1 and fib2. It should be a 1. It is a 1. Now we can test more cases. You'll find that it's computing the correct Fibonacci number. Let's try index 10. From the table we know we should be expecting 34. If we run it, indeed it is 34. Now let's polish it a little bit. What if we want to print out the entire sequence rather than a single number? So the one simple way to do that is just to create a for loop that wraps around this get fib number vi. So let's bring up a new vi and create a for loop here. So a for loop, and we want to assign this to our control, which is the input. So let's call it sequence size, which is a natural number. And in this loop, so we need a internal variable that stores the intermediate value of the sequence, because the sequence is an array. So let's create an array. So here, connect that, and let's change that to shift register because we will need to pass that value around. So now we need the insert into array block, and we want to call the vi that we just created, which is the get fib number right here. Now here it's a little bit tricky that you want to add the I is the index of the for loop, which starts from 0. However, in our case, we defined the index such that it is always a natural number, meaning that it starts from 1 and it's never going to be a 0. So you actually want a +1 here before you pass that into the input of the get fib number vi. And insert that. And create an indicator. So let's call it fib sequence out. And let's test it. Let's do sequence size is 10. We should expect it to print out these 10 numbers. And let's see if it's correct. So we expand that. As you can see, let's put these side by side. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Exactly as we expected. Thank you very much for